Hello everyone, welcome back to another video of Arnab Code. This is Arnab Agrawal right here, and in today's video I'm going to be talking about time complexity and how you can use it to solve problem. Alright, so let's begin. Alright people, so before starting and learning about time complexity, let's look at this sample problem right here to demonstrate how and why time complexity is so important here. I would like to give you the crux of this problem statement right here. So what we are actually wanting to do here is basically we just want to minimize the elements in a array, reduce all the elements in the array to the minimum, to the value of the minimum element of the array. Like here it's 5, so we would reduce all the elements of the array, which is 1000 here, to 5, and we need to output how many moves we would need to do that in. There are two solutions to this problem right here. So in the first one, what we are basically doing is we are first of all just checking if the array is already equal by default, and if it is, then we are just breaking the loop here, else we are just finding out the minimum element here, and for every element which is not the minimum element, we are just reducing the value of it, and we are doing this continuously, and we are just incrementing the move variable here, and we are just outputting that. This code would actually fail. You know why? Because this would give us a time limited exceeded warning right here. This is the actual solution for this problem. So what we are doing here is basically we are just finding out the minimum array here, and then we are just using a clever mathematical formula here. Now this is nothing advanced. What we are basically doing is we are just trying to find out the difference between elements of which is not the minimum element and the minimum element. Like here the difference would be, so if I do 1000 minus 5, so that would be equal to 995. So if I multiply that by 5 here, boom, we are getting the answer here, which is 4975. So this code exactly does that, and you might think that both of them give the same result, but why does one accept and why does one not? And here is exactly where the concept of time complexity comes. So now let's finally understand how time complexity works and how it can actually determine whether your solution gets selected or not. So for time complexity, I am going to use a pen analogy. In a way, we write the different time complexities here. There are many more time complexities. Some of them are too complex to be in the scope of this video right here, but these time complexities are the ones which I have actually found myself frequently utilizing and coming across. So for the pen analogy, talk about basically me giving my pen to a class of 100 people, and O and time complexity right here would actually signify that I individually go up to every single person and ask them where my pen exactly is. O n square here would basically signify me going to one person asking where my pen is, him going to another person asking where my pen is, and that loop continuing till we reach the last person and actually finally find the pen. And O log n here is actually a bit of an interesting one. So basically we are dividing the 100 people into group of 2, like 50, 50. One has the pen, one does not. We further divide it into 25, 25. One has the pen, one does not. And this goes on further and further till we actually reach to the one person who has the pen here. Now, what's the context of this analogy right here in my code? So as you can see, this was the code which I used in my solution of the problem. So what we are doing is basically we are first of all using one for loop to take in the input of the problem here, and then we are just initializing this, and basically we are just first of all initializing this loop here. There is an interesting part here. Constant does not matter. This would actually simplify to 2n square. The times that we are using n here is basically 2n square. So this is one part of n. This is one part of n, and this is one part of, actually we would not say this is a part of n, this is a part of maximum, but for the sake of simplification we are just calling it n here, or technically a part of n. So all of this should technically simplify to 4n square, but it does not. The time complexity of this problem can be said to be O(n) square, and that is exactly what I meant to say. We are actually going to ignore the constants here. Alright, so let's continue. So this code actually is a bit different than the one that I showed you guys here. So as you can see, we are just basically having one loop here, and that loop is basically just responsible for taking in the input and also finding the minimum element of the array and also maintaining the sum. So the time complexity can be said to be O(n), because basically we are only having one loop which is just accessing the n number of inputs only one time. So this code is actually more efficient than the code that I showed you guys before. So this code would actually give you the accepted here. So as you can see, this is basically the different constraints for the different time complex. As you can see, the O n time complexity requires the value of n, like the input size, to be 10 to less than 10 to the power 8. O and O log n or O1 can accept the value of n which is greater than 10 to the power 8. So this is the most efficient theoretical algorithm, and O(n) square accepts a solution which is less than 5000 in input size. So as you can see, for the constraint of this problem would happily accept a O(n) solution, but it would not accept a O(n) square solution. So that actually proves the point that why do you need time complexity to solve problem. Oh, alright people, that does it for today's video. I hope you enjoyed this one. If you really did, please do like, share and subscribe. This is Arunabh Agrawal signing off. Thank you.